Okay, so we're finally done with radicals. Well, kind of, but now we're going to move on to imaginary numbers. The things to remember here is if we want to write them in terms of I is equal to the square root of -1, or I squared is equal to -1. So those are the things, that's what you have to remember in terms of this. And you always take care of the i's first. So if I want to simplify this expression and write it in terms of I, the first thing I'm going to do, and I'll do this on the first one, is rewrite this as the square root of -1 times the square root of 25, which gives me I times the square root of 5 times 5, which is I times 5, or 5i. If I have the square root of -45, then I take care of the -1, so this is I times the square root of 45. Then 45 I have to break down if I don't know what the prime factorization of it is. So 45 is divisible by 3. When I divide by 3, I get 15. It's still divisible by 3. And when I'm done, I get 5. So this is I times the square root of 3 times 3 times 5. Of course, the 3 comes out. So you have 3 times I times the square root of 5. Or you can write it as 3 square root 5i. I accept either one. This is the way I've always learned to write it, but I think you may have to do it this way in Alex. Okay, the square root of -2. 32 is I times the square root of 32. 32 is divisible by 2, 16 is divisible by 2, so is 8, and so is 4, and I finally get down to 2. So this becomes I times the square root of 2 times 2 times 2 times 2 times 2. The 2 squared comes out as a 2. Another pair of 2's comes out as a 2. I have an I, and I have a square root of 2. So this becomes 4i root 2, or 4 root 2i. If I have the opposite of the square root of -1, I'm going to take care of the radical first, so this becomes just -i. Okay, the opposite of the square root of -20 is the opposite of I times the square root of 20. 20 is divisible by 2. That gives you 10, which is divisible by 2, and you get a 5. So this is -I times the square root of 2 times 2 times 5. The 2 comes out, so I have 2 times -I times the square root of 5, which is -2i root 5, or -2 root 5i. If I have the opposite of the square root of -144, I take care of the I first, so this becomes -I times the square root of 144. Hopefully we know that the square root of 144 is 12. If not, it's divisible by 2, which gives me 72 divisible by 2, which is 36 divisible by 2, which is 18 divisible by 2, which is 9, and 3, and 3. So this gives me -I times the square root 2, 2, 2, 2, 3, 3. So I have -I times 2 times 2 times 3, which is -I times 12, or -12i, and that's the preferred way on that. Okay, if I'm performing operations, if I am multiplying, I have to take care of the i's in each of these independently before I group them together. So this becomes I times the square root of 4 times I times the square root of 9. So this is I times 3 times, times 2, I jumped ahead of myself, times 3. So that's 2 times 3 times I, 2 times 3 times I squared, and I know that I squared is equal to -1. So that becomes 2 times 3 times -1, or -6. Okay. Same thing here. I've got I times the square root of 150 times I times the square root of 2. Now 150 is not a perfect square, 2 is not a perfect square, so I think I'm going to write this as I times the square root of 150 times 2. So 150, if I break that down, is divisible by 2, which is 75, divisible by 3, which is 25, divisible by 5, and divisible by 5. So this becomes I squared times the square root of 2 times 3 times 5 times 5 times 2. So I have I squared, I have a pair of 5s, I have a pair of 2s, and the square root of 3, which is all that's left in there. Well, I know I squared is -1 times 5 times 2 times the square root of 3, which gives me -10 root 3. If I'm adding, just think about it as combining like terms. I'm going to add the real components together, and I'm going to add the imaginary components together. So I can just reorder this since it's plus. I can just write this as 2 plus 11i plus 4 minus 7i. I'm going to group the real part together and the imaginary part together, which gives me 6 plus 4i. If I'm subtracting, I have to remember that that's adding the opposite. So this is -6 plus 7i. The opposite of -2 is +2. The opposite of 15i is -15i. Again, I'll group them together. The real parts are the -6 and the +2, and 7i and -15i. That gives me -4 minus 8i. And it does need to be written in that order, the real component plus the imaginary component. If I'm multiplying, same thing. Same procedure that we've always done, we just distribute. So this becomes -6i times 5i minus 6i times 4. This gives me -30i squared minus 24i. So this is -30 times -1. I squared is -1 minus 24i. So that's 30 minus 24i. Same thing on F. I'm going to distribute. So this becomes 8i times 9 minus 8i times 2i. 9 times 8 is 72i. 8 times 2 is 16. I times I is I squared. So that gives me 72i minus 16 times -1. 72i plus 16. And writing it in standard form, the real component comes first, so 16 plus 72i is the appropriate way to write that. Okay, if I have 5 plus 11i squared, I want to recall, we can do it two ways. We can know the pattern, or we can remember that this is 5 plus 11i times 5 plus 11i. If I use the pattern, if I have a plus b to the second, that equals a squared plus 2ab plus b squared. In this case, the a is 5, so that's going to be 5 squared plus 2 times a times b plus b squared. So that gives me 25. 2 times 5 is 10 times 11 is 110i plus 11 squared is 121i squared. So this is 25 plus 110i plus 121 times negative 1. 25 plus 110i minus 121. When I combine the 25, the real components, that gives me negative 96 plus 110i. This doesn't follow a pattern, it's just a binomial times a binomial. So I'm just going to distribute. So 5 times negative 3 is negative 15 plus 10i plus 24i minus 16i squared. So the only thing I have to do here, this becomes negative 15 plus, I'm going to go ahead and add these together, 34i minus 16 times negative 1. So negative 15 plus 34i plus 16. When I combine my like terms here, I get 1 plus 34i. And again, that's in the appropriate form. Okay, if I have 12 plus I times 12 minus I, this is a difference of squares. If I have a plus b times a minus b, this is a squared minus b squared. So this will become 12 squared minus I squared. 12 squared is 144 minus negative 1. So that's 144 plus 1, which is 145. If you don't remember that, of course, you're just going to FOIL it out. So that's 144 minus 12i plus 12i minus I squared. So that gives me 144 minus I squared, 144 minus negative 1, which is 144 plus 1, which is 145. Okay, I'll quit here and then we'll move on next to solving by factoring.